The first one we actually met as part of our telecom organization, and they were doing something very interesting with phased array antennas in terms of communication. Turns out it has applications well beyond telecom. So we're going to learn about them right now. So with that, I'd like to invite up Maha. She's founder and CEO of MetaWave. If we could get the slides for Maha and bring her up.
Thank you, Derek.
Thank you.
Thank you. Thank you, everybody. My name is Maha, and I founded MetaWave in January 2017. Thank you. Maybe you want to put my slides. In 2017, the technology spun out from Xerox PARC. If you know that Apple started with all the Xerox PARC cool mouse, so it was really quite an honor when they asked me to lead that venture. What we are doing, we're building the long-range radar with 4D with imaging capabilities. In the same time, the solution that we are developing addresses the 5G and wireless communications issues. So I will not cover the wireless. All what I want to say is that next week, we will be displayed in one of the major carriers in Tokyo, and hopefully we'll have some kind of news after that. We are 30 employees, mostly PhDs with a lot of experience. We raised $17 million round. I want to thank John for giving me a great introduction in his previous presentation, so we're honored to have Hyundai, in addition to other car OEM like Shanghai Electronics, as well as Toyota. You also see Infineon, so we have investors from the whole value chain, from the chip to the tier one. Denso led the previous round, and we're currently raising our Series A, going after 3 market, the Warlord radar that I'll be talking about, and then we have the Sabre for 5G as well for fixed wireless. So which problem we're solving? There is a missing sensor today. I'm a physicist, graduate from PhD from MIT, and I realized there is an issue, and the issue is, how can you go beyond 300 meters? It's important to go beyond that distance, because if you want to avoid casualties or fatalities, the car has to perceive the environment at this long distance. How can you see pedestrian beyond 200 meters? So these are all kind of issues that exist today, and I'm sorry if some people are trying to overhype the technology. These are all facts. How can we make our roads safer? How can we make the riding experience smooth instead of having abrupt acceleration and braking at a much lower cost? So what I wanted to show you, this is our first long-range demo. We did close the seed round last summer, so eventually we're only 5 months old. We did demonstrate our first radar. What you see here on the y-axis is the range. On the x-axis is the velocity. So the radar, yes, it's the only sensor that can detect the pedestrian and also measure the velocity. We also have an AI engine. So what you see here is the automatic labeling. So we distinguish between cyclists, pedestrian, and cars. That little orange square that you see in the middle is a pedestrian that's been able to be detected beyond 150 meters. And so this video is 2 months old. A couple of weeks ago, we had very heavy fog. Our office is just a few feet from the beach in Carlsbad. And we took advantage to take and measure the range for the pedestrian at this very heavy fog. And as you will see, we were able to detect Edmond at 220 meters. There isn't a single sensor today on the market or even in development. I don't care, it's a camera, radar, or LiDAR that's able to be detecting these pedestrians at these very long ranges. Very good. So how are we doing it? And you will see other radar companies talking about. There are 3 different ways of solving the problems. On the left, you will see the massive MIMO, and you'll see the digital beamforming. These rely heavily on digital signal processing. As a physicist, I wanted to bring analog back. In high frequencies, you have to solve the problem in the analog space. So zeros and ones, Moore's law, exhausted its capacity, and I'm bringing back the analog space in order to address this long-range, high-resolution radar. So we're squeezing that energy in a very narrow cone to go very far. We are steering that beam in horizontal and vertical direction using these metastructures. And also, we're doing it in a very incremental step, so we don't miss any objects along the way. That's the only way how to do it, and we will prove that it can be done. We filed over 70 patents, by the way. We are chip agnostic. We don't develop our own chips. You saw Infineon as an investor, but we are going to demonstrate the solution based on TI at CES. We welcome you all to come and talk to us about our demo. The main objective down the road is to go very far away, very narrow beam, 1 degree beam, very low interference mitigation. We solve the interference mitigation at the analog space, and also being able to steer plus or minus 60 degrees, a very wide field of view. And adding additional functionality, as you will see in this video. So what else I can do with the same hardware that other sensors cannot do? So as I mentioned to you, we're doing the radar. So this is kind of the perception of the environment. We do the machine learning because this is the only sensor that can see very far. There is no machine learning or AI at these ranges. We do the signature extractions of this object to train our radar, and eventually we will do simultaneous localization and mapping with these narrow beams. What we can also do, we can look along the corner. So when we see that there is a motorcycle coming around the corner, the car is already detecting it without even seeing it in the line of sight. All of this can be done with the same radar. So it's a multifunctional radar that also has the capability down the road to learn in a way to proactively create a predictive analytics to detect that there is a road issue and communicate via V2V communication to the other warlord radar. So that radar can also do the V2V communication. So just a summary, we can do the detection, range, velocity, speed, and object classification. That's why it's a 4D radar capabilities. We can do simultaneous localization and mapping. We can do the V2V communication and the non-line of sight detection. I've given this presentation multiple times. I will always finish before my 8 minutes. Last slide is tell you a little bit about the 4G and 5G. As you know, this is the analog portion. Since I'm transmitting it, either I'm detecting a reflection or I'm detecting a communicating signal. We are working with the carriers directly. The lower left side is the relay, and we will have more announcement about our Saber relay. We bypass all the radio vendors. Eventually, we're also going to work with the radio vendors and the radio OEM to help them accelerate the deployment of the 5G in a more economical way. We will be both at CES at the Mobile World Congress. Thank you.